Hi students, welcome back to Wisdom Academy YouTube channel. In the previous video, we have learnt about the concave mirror and the image formations by concave mirror. We have learnt how the ray diagrams helped you to determine where the image will be formed if the object is kept at various locations. We kept the object at infinite, at C, beyond C, between C and F, at F, between F and P, and we found how the images are formed. I hope you are clear in that. I have told in the previous video itself that you should have all these data in your mind and no need of mugging it up. If you keep on practicing it, within few days you will see that automatically you start remembering where the image will be formed for which condition of object position, right? So before I enter into convex mirror conditions, I wish to tell you about the use of concave mirror. Mind that it is important for the examination. What are the different uses of concave mirror? Now, concave mirror, it has various conditions. What I mean to say is that it can form both real image and virtual image. By now you have learnt about plane mirror and concave mirror. Plane mirror, in any condition, wherever you keep the object, it forms only virtual image. It can never form real image. But a concave mirror has a capability of forming both real image and virtual image. When the real image was formed, if the object was kept at infinite, beyond C, at C, between C and F, till it was kept at F, all the images formed were real and inverted. Only when you kept the object between F and P, it became a virtual image, right? So we have to be very careful in using the concave mirror, because same mirror can give a real image, it gives a virtual image. So if it gives a real image, it can only be obtained on a screen. That means if you don't have a screen, you cannot obtain it. So it can only be obtained on a screen. So definitely I cannot use it where I don't have a screen to obtain an image. So suppose I want to see myself in a concave mirror, I cannot see it until I come between F and P. So it has very limited use. For example, it is used mostly in the case of headlamps. So headlamps of I'm to say that vehicles. So if you see the vehicle's headlamp, they produce a powerful beam of light. How it is kept, they keep the light. Suppose this is the mirror, they keep the light somewhere here. Have you seen this surface is a silvered kind of surface and concave in nature. So what happens when you glow a light here such a way that it is at the focus, you get a powerful beam of light. You get a powerful beam of light outside, because we know that any ray which passes through the focus becomes parallel to principal axis. So all these rays which is passing through focus will become parallel to principal axis, and you will with this light you will get a powerful image. So this condition of concave mirror is used in the headlamp of the vehicle. So suppose in the examination, if they ask you that concave mirror used in the headlamps of vehicle, explain how, then you must explain with this kind of diagram. It is also used in the case where, like torch, same principle. Torch is there. Have you seen old age torch where there used to be a bulb, and if I draw something like this, it used to be in this shape, remember? And here we used to have the bulb inside. So this, in the back side of the torch, we used to have a silvered surface, a kind of concave mirror, where if the light was kept at the focus, it used to give a powerful beam of light. So these were the conditions where the concave mirror was used by keeping the object at the focus. Also, concave mirror is used by dentists to see the teeth cavities. How? Which condition they use? They use the condition when the object is kept between F and P, because if they don't use this condition, what will happen? They will not be able to see any image in the mirror. So what they use? They use this kind of mirror. So you remember that if the object is kept between F and P, the first ray will go pass through focus, second ray will come from here, and they both will meet to form a virtual and enlarged image. So if the image is virtual, it can be, there is no need of screen to obtain it, without screen also. So inside the mirror itself we can see, and it is enlarged image. So this property of the concave mirror is used by the dentist to see the cavities in the teeth. Not only this, it is also used by the makeup artist for the makeup of actress. So, actor and actresses. So, when this makeup mirror is used, we can see our face more clearly with more pores, and if there is any correction to be done, they are doing the corrections. So, this case is used for enlarging the image and getting the image inside the mirror itself, and this case is used to make powerful beam of light. So, if the question is asked like what are the uses of concave mirror, you can write it is used in the headlamps of the vehicles to get a powerful image, a powerful ray of light. It is used in torches. It is used by the dentist to see the cavities of the teeth. It is used by the makeup artist for doing the makeup of actor and actresses. These are some common uses of concave mirror. Now we are going to see the image formation by a convex mirror. So I have already told you what is a convex mirror. It is a mirror which is polished from inside and reflecting from outside. So something like this. So if I draw, this is the polished side and this is the reflecting side. But mind that this mirror being derived from a spherical glass, it has its center of curvature on this side. Also it has its focus on this side. But can we keep the object on this side? We can't keep the object on this side, because if we keep the object on this side, there will be no image formed, because always we should keep the object on the reflecting side. So here we have to keep the object anywhere. So can we have many cases in convex mirror? We cannot have, because anywhere you keep, it will give the same condition. So we can try that. So first ray is passing parallel to principal axis, it passes through focus. Here it will not pass through focus, it will get diverged and seem to pass through focus. And second ray, what we can take, center of curvature. So a ray which is passing through center of curvature, or I'll say which is supposed to pass center of curvature, will go back in the same path like this. Or this ray which is supposed to pass center of curvature will go in the same path. What is the point of intersection? Somewhere here, and see there is a virtual image formation. This was A, B, this will be A dash, B dash. So wherever you keep the object, where the image is formed between F and P. So if I want to write the nature, first what we are writing, the location. So what is the location? Location is, it is between P and F inside the mirror, inside the mirror. This is the location. What is its nature? It is virtual and erect. It is virtual and erect. And what is its size? It is diminished. It is diminished. So I am saying if you keep it anywhere, if suppose this object would have kept here also, same will be the image formation. It will be a diminished image, it will be virtual erect, it will be between pole and focus inside the mirror, right? So one more case is possible, that is keeping the object at infinite. So this is the convex mirror, let here be F, let here be C. So I am writing here, this was first case when the object is kept in front of mirror, and this is the second case where the object is at infinite, it is at infinity. So when the object is very far at infinite, one ray will come parallel to principal axis. What will happen? It will diverge and it will be supposed to pass through focus. Second parallel ray will come, it will again diverge in such a way that it is passing through focus. So if you see, all the rays will meet at this point only, and the nature in this case will be first its location. Where is the location? At focus. So when the object was infinity, again the image formed at focus, again behind the mirror or inside the mirror, whatever you want you can write, inside the mirror. Definitely it is virtual and erect, and it is point sized, it is highly diminished. So, we will say it as point sized. So, there are only two cases of ray diagrams possible in the case of a convex mirror. One thing, when the object is kept anywhere in front of a convex mirror, and second case when the object is at infinite. So, in both the cases we get only a virtual image which is diminished or very highly diminished, and it is either at the focus or at P and F of a convex mirror. So, this is about the image formation by a convex mirror. Now, let us talk about its uses. So, what can be the uses of a convex mirror? Now, you see, the condition of convex mirror is it will form a virtual image but a diminished one. So, can we use it in dentist? No, we cannot use it by dentist. The reason is, if dentist will use, already the holes are very small, cavities are very small, it will become further small. So, definitely do not expect that this convex mirror can be used by dentist or either by makeup man. No, it is not. It cannot be used by them. It can be used somewhere where we have to reduce the size. It is very important use of a convex mirror is that it is used in the rear view mirrors of the vehicles. Have you seen in a bike or in a car, the mirrors are there, no? It is written on that object which are present can be nearer than they seem to be. You know why they were writing that? Because if you see here, even the object was kept this much far, image is formed here itself. Or even the object is very near, it will form there itself. So, it will not give you the correct position of the object. But yeah, why we are using this then? Because we want to get the more area cover. We want to get the more vehicles. If I use a plane mirror there, I may get the same size, but only one size will come. So, I will not be able to see the whole vehicle. Do you get what I am trying to say? So, if suppose I use a plane mirror, then a bike is coming or two buses are coming, I will not be able to get all the image. I may get only the portion of bus. But if I use a convex mirror, then more number of vehicles can come in that same screen and everything will be little smaller. Mind this. So, object in a convex mirror is small. So, one of the most important use of convex mirror is that it is used in the rear view mirror of the vehicles. Also, you think where else it can be used? It can be used only where we have to reduce the size. Right. So, have you seen in the parkings or where we have to take a turning in the buildings, you would have seen there are some mirrors kept, like round kind of mirrors. Those mirrors are again convex mirror. Whenever you are going to take a sharp turn to see a image of who is coming at the back of you, they are using that. So, you can locate them, and it is also used kept in the buildings, that kind of mirror. It is also used this this convex mirror. If you think what are some other uses of convex mirror, what comes to your mind? See, I am telling you again and again, your aim is to find where the object size is reduced and you are getting the image. So, where else can a convex mirror be used? If you think about that, most of you would have gone to ATMs. Have you seen in ATM, there is a silver color thing at the top of the ATM. It looks like some mirror. That is again a convex mirror. You know why it is given? It is given to see whether someone is seeing you from behind when you are putting the pin. So, suppose someone is seeing you behind, you can have a view and you can see, yeah, someone is seeing me. So, for that security purpose only, they always give a convex mirror in the ATM machines also. These are some of the uses of convex mirror. So, in today's class, what we saw what are the uses of concave mirror. Then we saw what are the various image formations. There was only two by a convex mirror, and we also talked about the uses of convex mirror. Today, after this class, we will start solving the numericals based upon it. We will go into the mirrors formula. That is very important in this chapter. So, we will meet in the next session. Thank you very much.